All right, now let's look at another word problem. This says the number of cancerous cells, n, in thousands can be estimated by the function, and here's the n in thousands, 225 minus 4x squared, where x is the number of days of radiation therapy treatment. So I guess somebody comes in, they have a cancer cells, thousands of them, and then they undergo radiation, and then the idea is that the number of cancer cells maybe would go down. You might also see this written as negative 4x squared plus 225, right? Is that the same thing? That's the commutative property. So then you might recognize A. What is A, B, and C? If I wrote this in standard form, I have n of x equals negative 4x squared. How many x's are there? You don't see any. So how many are there? 0. That threw you guys off earlier when you were doing the activity of B. So that the only reason why I point that out is because if you were going to identify A, B, and C, you might want to know, what is B? It's 0, right? B is 0. What is A? And what is C? 225. So that could be helpful in terms of standard form. Okay, what are the units that for the x-axis? Yes, number of days. Okay, and what are the units for the y-axis? Number of cells in thousands. So if we go to our graph down below, we can put here, this is days, and these are cells in thousands. I'm just going to put 1,000 here. Okay. All right, coming back up. Initially, how many cancer cells are there? Interpret your results in a complete sentence. What would you say? How would you answer that? Yeah, n of 0 is 225, because if you plug in 0 for x, that's initially is on day 0. So that's the ordered pair 0, 225, which we call the y-intercept. So how would you interpret it in a sentence? Okay, I'm writing initially, but the same thing, 0 days. Initially, there are 225. Are there only 225 cancer cells? Oh, 225,000 cancer cells. Okay, and that's where we see that in thousands from the original problem. Algebraically determine the number of days there will be 125,000 cancerous cells. So remember that this function is already in thousands. So what am I going to do to solve this? This is algebraically determined. Basically, they want to know n of x equals 125. We want to solve n of x, because we don't know the number of days. We're going to try and find out how many days. We have 125 left. So if we take the original equation, 225 minus 4x squared, and we set it equal to 125, now we're going to solve for x. So what could you do to get x by itself? What method of solving would you want to use? Solve by factoring, quadratic formula, or square root. Why is square root so convenient here? Yes. You can isolate x squared, and how do we undo? If I can get x squared by itself, isn't that negative 100? Divide both sides by negative 4. X squared equals 25. And then what are we going to do from here? The square root. X squared equals plus or minus 5. Now, when it comes to this word problem, could you have negative 5 days? Can you undergo cancer treatment for negative 5 days? How would that work? Yeah, it wouldn't work. You can't have really a negative time. You can only have time going forward. So we would exclude the -5, even though it is an answer to the problem, to the equation, it doesn't work in terms of the context. So we would say after 5 days, the cells are, or there are, how about there are, I'm like, is that the right there? There are 125,000 cancerous, or I'm just going to say cancer cells. You can write cancerous. Oh, it's right there. Okay, so any questions on that? Setting it equal, we chose which way to solve. Now this says algebraically determine how many days the treatment is needed to kill all of the cancer cells. How many cancer cells will you have if they're all killed? 0. So we basically want to solve n of x equals 0. So what should we do with our formula? Take the formula, which is 225 minus 4x squared, and set it equal to 0. Perfect. And now we can use, can we use the square root method? So how would we solve? Yes, negative 4x squared equals negative 225. Divide both sides by negative 4, because we're isolating x squared. I don't happen to know off the top of my head, 225 divided by 4 equals 56.25. And then we want to take the square root of that, right? Did you guys get that when you divided that, 225? Okay. X is approximately, we only want the positive. I'm going to put the plus and minus in there so that we don't forget it for future problems, but we really only care about the positive one. So we're going to take the square root of 56.25 and we get 7.5. Oops, that's 75, 7.5. It's actually exactly equal to 7.25 or 7.5. So 7.5 is where we're hitting the, in a way, well, I would say hitting the ground, but this is not a ball problem, but we have no cancer on day 7.5. So what problem, if we're setting this equal to 0 and solving for x, what are we actually finding there? What point is this? If it's x-intercept, yes, x-intercept is going to be 7.5 comma 0. So we didn't find the vertex here, but let's plot. Now we want to plot some of these points that we found. So we found up here the y-intercept, 0 to 25. So we're going to plot that. What's the scale that's being used here? Looks like we're counting by tens, yeah? So 225 would be here, 0 to 25. That's where we're starting. That's the y-intercept, 0 to 225. And then we know that it's opening downward, so it's probably going to go up from here, maybe come back down. Well, actually, isn't this, the x-intercepts are symmetrical. Let's do this other point. So this other point was 5, 125. Do you guys have any idea about the what the axis of symmetry is? 5. Here's 5, 125. Who thinks they know what the axis of symmetry is? And then here is 7.5, 0. 7.5, 0. So this is actually coming down like this. The axis of symmetry, yes, is x equals 0, which is the same thing as the y-axis. Okay? But we only care about the positive numbers here. I'm not even graphing the negatives. And you can again use your calculator like I've shown to check some of those.